Hi, I'm Dr. Doug Richie, and today I'd like to demonstrate for you the importance of positioning the foot for taking a cast or a scan for custom foot orthoses or for a custom Richie brace. I'm going to demonstrate for you how to find subtalar neutral and also the importance of loading or locking the midtarsal joint for stability of the foot. Ultimately, this translates to stability of the foot orthoses and stability of the brace so that we get an optimal patient treatment outcome. Before taking the cast or scan for the custom foot orthotic or the Richie brace, I find it helpful to demonstrate to the patient what you're going to try to do with the positioning, because it allows them to appreciate the science behind the orthosis or the brace. And so once we get the patient comfortable in the exam chair, the first thing we do is we show the patient the motion of the ankle joint, and we show them that there's another joint in the foot. This is the subtalar joint, and it allows a much different motion than the ankle. And then we show them, after we stabilize the subtalar joint, we show them the midtarsal joint. And we show them that what we're going to try to do is align the foot optimally at really all of these joints for proper stability and function. I'm going to demonstrate how to palpate for subtalar neutral. I'm going to feel the head of the talus medially and the head of the talus laterally, and as we move the foot into pronation and supination, we'll feel a congruence of the head of the talus against the navicular, where it's not prominent either laterally or medially, where they're lined up at the talonavicular joint. There's no bump there, there's no bump there. So this is subtalar neutral. There's also a way to do it by visualization, where you put the foot through range of motion, and as it reaches the bottom of the dell, as we say, I'm exaggerating a swinging motion here, but as we get to neutral at the low point of the dell, it actually is, by palpation and visualization, the neutral position of the subtalar joint. We want to capture the foot in subtalar neutral because we want the midtarsal joint stable. We want it stiff and solid. If we cast the foot pronated, we've got a very loose, unstable midfoot. And it's really a good idea to try to demonstrate that to a patient so they understand what you're doing as a practitioner when you're going to the trouble to align the foot subtalar neutral and load or lock the midtarsal joint. This is how we want the foot to function with the custom device. We can lock that midtarsal joint by gripping the fourth and fifth toes and just lifting the foot. Or it is acceptable to push up against metatarsals 4 and 5, keeping the foot at subtalar neutral and loading the foot. Traditionally, practitioners are trained to cast the foot in this position with the patient supine. This is not the optimal position to take a digital scan, because the person taking the scan is going to have to come all the way under the heel to capture the image of the calcaneus to the leg and come back out the other side of the foot. This is hard to do, to get under the foot and take that view. So what we're going to do is put the patient in a prone position, which is a much better angle for taking a digital scan, but it will require the practitioner to modify how they hold the foot during the scanning process. For sure, you don't want the foot just hanging like this and taking a scan. If you take a scan of the foot like this, it is not in a neutral position at the subtalar joint, and there's all this play available at even the ankle and the midtarsal joint, and there's angular changes that are captured in this relaxed position which are not desirable when you're making a foot orthosis or a Richie brace. We're going to show you a cast taken of the foot in this position and a cast taken of the same foot in this position, and you will see significant differences in alignment, shape of the arch, and contour of the borders of the foot. We've taken 2 casts of this patient simply to demonstrate the difference in shape when the foot's hanging in space, which is the cast on the left, and then the cast on the right side. The foot has been properly positioned in subtalar neutral with the midtarsal joint locked and fully pronated. Look at the difference between these 2 casts. Look at the bisection of the calcaneus from the back or posterior view, and look at the forefoot to rear foot relationship. It is very clear to see that there is a deformity in the left hand cast which is not visible in the right hand cast. If we turn the negative cast over and look at the plantar surface of the foot, the arches are shaped differently, and the lateral border of the foot is shaped differently. The left-hand cast, where the foot was not positioned, captures a curvature of the lateral border, which means the midtarsal joint is supinated. If we make a foot orthosis from this supinated cast, the orthosis will be uncomfortable and it will not function properly because it will tend to supinate the foot at the midtarsal joint. The right-hand cast has been taken of the foot in a proper position where the midtarsal joint is fully pronated. This means it's locked and stable, and you can clearly see that the lateral border of the cast is straight. So the right-hand cast, where we've positioned the foot properly, is going to lead to a comfortable orthosis and lead to a much better treatment outcome. Okay, we now have the same patient in a prone position, which allows excellent visualization of this critical relationship of the calcaneus to the lower leg. This is a much better angle to take a scan, and in some ways is a better position for the patient even when we do a fiberglass cast or a plaster cast, because the practitioner gets a good visualization of where that calcaneus is relative to the leg. It's just a little more awkward in terms of loading the midtarsal joint and finding subtalar neutral, because the practitioner has to literally move to this side of the foot, as I am, to palpate and load the foot so that a scan can be taken. But basically, with the patient in this position, you do not want to take a scan with their foot just hanging in space. You can see this subtalar joint is inverted or supinated. The midtarsal joint isn't loaded. And we take a scan of this foot, we're going to capture this varus deformity of the heel and an improper alignment of the midtarsal joint that will pretty much doom the orthotic to failure, in my opinion. So with a little bit of extra effort on the part of the practitioner, we're going to position the foot, again feeling the congruency of the head of the talus, both medially with my index finger, laterally with my thumb, supinate and pronate the foot until that head of the talus becomes non-prominent medially and laterally, where it's lined up evenly on the navicular. And then we load the midtarsal joint. We literally dorsiflex the midtarsal joint and the ankle, keeping the subtalar joint in neutral. We can't really grab the toes like we do in a supine position. It's too awkward. But the lab will allow you to push your fingers on the head of metatarsals 4 and 5. They can adjust for this in the scan and even in the cast so that there's not a true distortion of the shape of the cast afterward. So we're going to have the patient just totally relax, palpate subtalar neutral, and now I'm going to push up on 4th and 5th mets, which effectively loads and locks the midtarsal joint. It also dorsiflexes the ankle. And I can just stand off to the side while an additional person, your assistant, can take the scan from all angles. Or if you're still using fiberglass or plaster, you can apply the material and just hold the foot with your fingers against metatarsals 4 and 5, keeping it in subtalar neutral, midtarsal joint fully pronated and locked. This is the ideal position for casting or scanning for a custom foot orthosis or for a custom Richie brace. This position is much different than a relaxed hanging position, which will be not optimal and probably have a failure in terms of the treatment outcome.